All right, 6.3 confidence intervals for population proportions. So, population proportion, we're going to start the same way we did with population means, where we started with the mean. So, a point estimate for P, the population proportion of successes is given by the proportion of successes in the sample. It's denoted by P hat. Okay, so we read it as P hat. Got a little hat, cute little hat on it. This is equal to X, okay, number of successes, divided by N, okay, total number of trials. All right, sample size, right? This is the total sample size. Now, Q hat, remember P and Q? If P is the probability of success, Q is the probability of failure. So to get Q hat, we use the complement rule. If there's a 30% chance of success, there's a 70% chance of failure. That's 1 minus P hat, right? This is the proportion of failures. Okay? So you might write your answer as a percentage. So if you had like a P hat equal to 0.52, that would be 52%. You might see something like that. Okay. So let's talk about confidence intervals. If I have a C confidence interval for a population proportion P, then P is stuck between the point estimator and the error. Okay, the point estimator and plus or minus the error as usual, where the margin of error here is equal to ZC times the square root of P hat Q hat over N. Okay? So what I want you to know is that margin of error E is equal to ZC square root P hat and then 1 minus P hat, because that's Q, over N. Okay? So this is true. When can we use this Ferrari? When N P hat is greater than or equal to 5 and N Q hat is greater than or equal to 5. Okay, if that's true, then we know that the sampling distribution for P hat is approximately normal. Okay, so what does that mean? So the sampling distribution for P hat is approximately normal with the mean of P hat equal to P, and the standard deviation of P hat is equal to square root of PQ over N. PQ over N. Okay? So, let's run through an example. Let's run through an example here, now that we've got our theory out of the way. In a survey, 1,000 people, 680 say that they use Facebook. Find the point estimate for P hat and Q hat. Construct a 95% confidence interval for the population proportion of people who use Facebook. Okay, so let's do it. First thing I do is I look at the numbers. What is 1,000? 1,000 is how many total people there are. Okay. What is 680? 680, we consider the successes. Okay, that's how many people say that they use Facebook. 680. So it's a success if you use Facebook. So to find p hat, I do x over n. So that's 680 divided by 1,000. This is going to be 0.68. 0.68. Now to get q hat, all I have to do is 1 minus p hat. So 1 minus 0.68 gets me 0.32. So now I've gotten those two things. And I'm asked to construct a 95% confidence interval. To do this, to use our Ferrari, we got to know NP hat and NQ hat is greater than or equal to 5. So N is 1,000. And so multiply that out, that's 680. So that's definitely greater than or equal to 5. NQ hat, that's 1,000 times 0.32, which is 320, which is definitely greater than or equal to 5. So therefore we can use the Ferrari. The Ferrari says that my error is equal to, the margin of error is ZC square root what? Square root P hat Q hat, right? Over N. Okay, so I need to calculate these values. Now, a 95% confidence interval, okay, 95% confidence interval. What type of chart am I going to? Am I going to a Z chart or a T chart? Okay, what am I using? Well, what do I know? It tells me Z, so I guess I'm going to be in the standard normal. So go pick out your standard normal table. So I'm going to go here to my tables. I'm going to try to look it up. So what am I looking for? All right. I want a level of confidence equal to 95%. That gives me 1.96. How easy is that? That little corner there is going to be your best friend when it comes to working these out. 95% level of confidence, 0.9196. Okay, so let's go back to here. So my ZC is 1.96. Now, if I didn't remember that, I could figure this out on my own. If I know there's 95% in here, that means there's 2.5% over here, and there's 2.5% over here, right? So I know that this area is 0.0250, and I go look up that number in the Z chart, find Waldo, and I got Z equals negative 1.96, and then that means on the positive side, it's Z equals 1.96, okay? So that would be how you would find it using, your head, and if you want to use the chart in that little corner level of confidence, you can get it by that as well. So P hat, so I've got P hat, which is 0.68, and then times 0.32 divided by 1,000. All of that square rooted. You need to be careful when you're doing this in your calculator. When you're doing it in your calculator, I would suggest doing the inside of the square root first. So 0.68 times 0.32 divided by 1,000. And then take the square root of that. So I do second square root, second answer, and I hit that. And then I multiply by 1.96, and I get 0.0289. So this gets me 0.02891, right? So I'm getting a little crazy there with my decimals. So what does this tell me? What's that tell me? Well, what's in the middle of my interval? The middle is the p hat, right? And then I have p hat plus my error and p hat minus my error. So I want a confidence interval, a 95% confidence interval. I've got my error already. So all I have to do is type it in. So my p hat is 0.68, that's in the middle. So I have 0.68 minus 0.0289, and then 0.68 plus 0.0289, and then I'm going to get 0.6519 over here, and 0.6, I'm sorry, not 6, but 7089 over here. So what does that tell me? With 95% confidence, we can say that the population proportion of U.S. adults use Facebook is between, I don't know, 65.2% and 70.9%. All right. So we're 95% sure that between 65 and 70%, 71% of people use Facebook. All right. So we're not saying exactly 68% of people use Facebook. We're just saying we're 95% sure it's between 65 and 71. All right. So in the real world, that's kind of wonky. So what you might read in a newspaper is it might say, survey says 68% of U.S. adults use Facebook, margin of error 3%. So that's how it would be written out in a newspaper. All right, they give you the point estimator 68%, and then they might say plus minus 2.9%. That would be about as technical as you would see in a paper. Okay. Now, one way to increase the precision of a confidence interval without decreasing the confidence level is to increase the sample size n. If I increase the sample size n, okay, then I can increase the precision. I can be more sure. So given a C confidence level and a margin of error, the minimum sample size, running out of room here. Oh my goodness, come on, one more time. Okay, the minimum sample size n needed to estimate the population proportion P is equal to, so it's n equals P hat Q hat times ZC divided by the error all squared. Okay, so if it's not a whole number, then round up, just like you did in the last section, okay, in 6.1. If n is like, even if it's like 14.2, I round up to 15. I can't sample 0.2 people. You're not going to ask somebody's leg, how you doing today, leg? Don't ask them that. You're going to round up to a whole person. Okay. Estimate with 90% confidence the population proportion of adults who think Congress is doing a good job. Interesting. Your estimate must be accurate. to within 3% of the real population proportion. So there's two scenarios going on here. One scenario is when there's no preliminary information available and you want to find the minimum sample size. Scenario 2 is you went out and you did a survey and 25% of people said that they thought they were doing a good job. You know, even after we get these $1,000 checks, yeah, be doing a real good job, right? Maybe that'll bump it up to 30%. Okay, so in the first scenario, part A, we have no preliminary estimate. If there is no estimate, then we assume there's a 50% chance of success, 50% chance of failure. Okay? That's what we assume. Just go right for it. 50-50 shot, just like flipping a coin. We don't know anything, so that's our best guess. Now, to be 90% confident, because we got to think about this. We're finding n, right? The minimum sample size, I want n. So I automatically think about my formula. N equals P hat Q hat ZC over E squared. So I know P hat is 0.5. I know Q hat is 0.5. I need ZC and I need E. So ZC, okay, 90%. So I go to my table and I look up 90% confidence. What is 90% confidence? That's 1.645. Told you that'd be an important one. 1.645. So I go back. Okay, let me go back. This wasn't efficient. All right, so ZC is 1.645. Now there's only one number left, and that's E, and that's accurate to within 3%. 3% in decimal form is 0.03. Okay, 0.03. When I type this in my calculator, I get 751.67. You gonna go out and ask 0.67 people? No, you better not. So N is equal to 752. It's at least 752 that it would take. At least asking 752 to be within 3% margin of error, okay, for the true proportion. That's how many people we'd have to ask if we had no preliminary information. Now think about this, our little analogy I used before we left for the break. N is the amount of information we have. N equal to 752 is a lot. But if I know more information, okay, I already know 25% of people think Congress is doing a good job, then am I going to need to go out and collect a whole lot more data to be 3% away from the true population proportion? No, I'm not going to need as much information because I already have more information than over here where I had no information. So let's try to work this out. N equals P hat Q hat ZC over E squared. So P hat and Q hat are all that's changing here. P hat, people that found that they were doing a good job, is 25%, so that's 0.25. If 0.25 think they're doing a good job, then that means 75% think they're doing a bad job. And I still have the same ZC, which is 1.645, over the error, 0.03, all squared. Type it in your calculator. What do you get? You get 563.755. Rounds up to N equals 564. Okay? At least 564 need to be asked. That's less people over here. So what's easier? Going out and asking 752 people or going out and asking 564 people? Well, I mean, it depends on how hard it was to gather the information previously from asking people. If there's 25% people like what Congress is doing. So that really is where the question hinges on. So if no preliminary estimate is available, then you will need a larger sample size to get the same level of error, margin of error, as you would otherwise. Okay, guys, this ends test 3 material. So make sure you go through, do all the homework. Very important that you do the homework, because the test questions will basically be homework questions, okay? So make sure you understand what's going on here.